Oh, sorry. And are you able to see my screen?
Yeah, I will. If I feel you are not going to stop within 5 minutes, I will give you a reminder at 4 minutes. But
Okay.
if I feel you almost finished, I won't say this. Okay, but I will stop the session anyway. At the seventh minute. Okay.
Okay, sir. Okay, so let's get started. Okay, hi everyone. Welcome back to machine learning. Today I'm talking about the linear regression study and implementation model, which is option one in our assessment. First, the definition of linear regression. It is a supervised machine learning models and one of the most renowned machine learning models used to predict the value of a variable based on the value of another variables. And within the project, we aim to find fit slide representing the correlation of these variables, and this slide indicates a continuous predicted output where the model has never seen the input data before. And to find a line, we use the hypothesis function, which is expressed as below. So how does the model learn? The hypothesis function provides dependent variable y to indicate the linear relationship between the independent variable x and the model parameters. So during the optimization process, the model used batch gradient descent to minimize the difference between the actual value and the predicted value, which is the mean square error loss function. The goal of the optimization algorithm is to find the most optimal value of weight and bias to minimize the loss function. So during the process of researching the project, I faced various challenges, and to name some, I would like to mention with you. The first one is overfitting. So when a model fits too much in the training data set, so unexpected patterns will happen, and therefore the model performs poorly on unseen data. The second one is categorical data. So the model designed to work with numeric variables only. So however, in my data set, some categorical data occurs, so I need to turn it into numeric data. And therefore, I have studied in detail about regularization and categorical data encoded. About the regularization, it is a crucial technique used to ensure no overfitting happens in the model, especially when dealing with high-dimensional data. So it occurs when the model learns not only the underlying patterns in the training data, but also the noise, which might cause poor performance. And the reasons why it is important and necessary are it could help avoid overfitting, simplify the model, and optimal performance on unseen data. So there are two types of regularization, but in the research, I will use right regularization L2. Yeah, there are many benefits of using this technique. About the categorical to numeric variables, I use label encoding, which help me to convert to integer label, and it is often used for ordinal. Yes, and on the other hand, the one hot encoding is used for nominal data. So let's jump right to the implementation. And due to the time constraint, I will mainly talk about the last model, which is the best, the most optimal model that I have built so far. So the first step of implementing is import some necessary libraries and do data exploration. And data preprocessing, which I have done here, is I split the data and then I categorical data encode the categorical data into numeric variables and do some data scaling. The most important part of this one is I would like to talk with you is the model constructing. So the fit method is responsible for training the model by learning the optimal values for the model's weight and the bias. So it uses gradient descent to minimize the difference between the predicted values and the actual target values. And the model is trained iteratively through the gradient descent process, which runs for a number of iterations. So from like 42, it's just a predict function. And I have applied L2 regularization in my binary model and with also hyperparameter tuning, which helped me to find the best MSE and the best parameters, which is the learning rate is 0.1 and the L2 penalty is 1. So if you compare my current model, which is implemented with L2 and hyperparameter tuning, we can realized that this is the best model we ever built so far compared to this one. This is also multiple linear regression, but there's no hyperparameter tuning and no L2 regularization. And the first one is, you see, simple regression model. Okay, thanks very much for your time. And this is, I would like to appreciate you if you have any questions to us.
Hi, sir. P2, thank you so much for your presentation. So I have the question for you.
Yes.
I noted that for the loss function, are you picking the MSE, not the MAE? Can you explain why you chose it?
Yes. So thank you for your questions. That's actually a great point. The MSE function. So why not MA but MSE? So mean absolute error is, you know, both can be applied to be the metric of to measure the model, but I use MSE because I want my model to be sensitive to larger errors, and also MSE is more sensitive to outliers, and I expect my data to may contain outliers that are important to the prediction task. But also when I do the research, I also find that on some resources it say the mean square error can lead to a unique optimal solution. So that's why I'm using MSE but not mean absolute error.
Yeah, hi, I'm a P4, so I have a question for you. So why did you choose the linear regression for this problem, not the logistic or something else?
Yes, thank you. Great questions. I would like to answer with you. The very straightforward answer is that the linear regression model is, you know, is very much easier to implement compared to the logistic regression. And to me, it is simple, interpretable, and it works well when there's a linear relationship between the features and the target variables. So in my project, there are many external features like our studied previous course and extracurricular activities of a student. So it might be it have a strong impact on the target variable, which is performance index. So making a linear regression is a suitable choice. Does that satisfy your concern?
Sorry, can I interrupt a little bit? I because I sorry for that. I lost track of the previous question. Who asked the previous question? Can you identify yourself again? The first question was
The first question is from me, P2, why he picked the MSE over the MAE.
yeah. Good.
P2, yeah.
And the second is a very generic and interesting question. Why pick up this this model family? Who asked the question?
It's me, P4.
Thank you.
Yeah.
Okay. Thank you. You continue. We still have time for one more question.
Hi, I'm P5. So I saw that you implement the L2 regularization. So I want to ask why you use it instead of the L1.
Okay. Yeah. Thank you for your questions. Very good point. So during the process of researching the project, I realized that L2 regularization works well when I have many features. So it helps smooth out the model by penalizing large coefficient, and also it is said that L2 is smooth and compatible to radian descent based method. So, and also furthermore, in handling overfitting, L2 regularization is a very important part to prevent the model from becoming too complex by reducing the impact of individual features with large weight and it could help minimizing the overfitting. Yeah.
Okay, thank you. Impressive project.
Thanks very much.
Okay, it's good. I think this is a very clear implementation, clearly presented project. So I ask you a question is that for regression model, you minimize the mean squared error, right? And using the gradient descent, and you have introduced that in your project. But on the other hand, could I ask why we need to engage in a gradient-based method rather than just directly compute the solution? Have you ever considered this possibility?
No, sir. So when I do the research, the online resources say gradient descent techniques could help. We choose it is a very useful and reliable optimization algorithm to ensure a stable convergence to keep a small number of objects as possible, because I am dealing with the entire dataset at once.
Good. Fine. I just want to remind you that for loss as regular as the squared error, you do not necessarily need a iterative-based optimization, which means you do not need to find the best hypothesis one step by another. This loss function is simple enough that you can directly pick it out from the parameter space. But on the other hand, if you engage the MAE, the absolute error, then you have to use, you do not have a direct solution of the global optimal. You need to use an iterative method. Okay, anyway, fine. It's good. So let's move on. By the way, I just have a drop-in request. That is because we have some arrangement which is very popular, very busy time of arranging things. Anyway, now we have a presenter who want to join this session, and I